Heat transfer. Heat transfer is the science which seeks to predict the energy transfer which may take place between material bodies as a result of temperature difference. Heat transfer occurs when there are two systems of different temperature because everything will always seek thermal equilibrium. Thus, heat will transfer from hot system to the colder system. Heat is the energy of a body or system that moves to another body or system due to the difference in temperature. Heat may be transferred from a hot temperature region to a lower temperature region but never from a low temperature to a higher temperature one. Unless there is an input of work. Like in our refrigerators and air conditioning units. In a refrigerator, we can keep food items longer because of the lower temperature even if the outside temperature is hotter. And we can lower the temperature of a room by using an air conditioner. There are three modes of heat transfer: the conduction, convection, and radiation. Conduction is a mode of heat transfer in which heat is transferred by molecular interaction through bodies in contact. Heat may also be transferred by conduction from one body at high temperature to another at lower temperature if the two bodies are in physical contact. In short, conduction occurs between solids, where heat flow is equal to the thermal potential difference over the heat resistance. Next is convection. Heat may be carried from a higher to a lower temperature region within a gas or liquid by moving masses of liquid. In short, convection is a heat transfer that occurs within fluids. There are two types of convection: the free convection or the natural convection and the forced convection. In free convection, the substance moves because of the decrease in its density, which is caused by increase in temperature. The greatest example of free convection is with air, because as air heats up, its density decreases, and as its density decreases, it will move up the atmosphere, and the colder, higher density air will go down. Next is forced convection. In forced convection, the substance moves because of the application of mechanical power, such as that of a fan. In forced convection, we use work, or we apply work to the fluid to cool the system faster. Like what we are using in our computers. We use fans in our computers so that it will cool the system and not overheat. To express the overall effect of convection, we use the Newton's law of cooling, which is Q is equal to H times A times the difference in temperature, where Q is the heat transferred in watts, H is the heat transfer coefficient in watts per meter squared Kelvin, and A is the heat transfer area. TW is the temperature of the plate or the object. Then T infinity is the temperature of the fluid. An electrical resistance analogy can also be drawn from convection process by writing the equation Q is equal to TW minus T infinity over 1 over H times A, where now the 1 over H times A is equal to the convection resistance. And last is the radiation. The energy emitted by matter in form of electromagnetic waves or photons as a result of change in electronic configuration of atoms or molecules. In heat transfer studies, we are interested in thermal radiation, which is the form of radiation emitted by bodies because of their temperature. Radiation is a volumetric phenomenon, and all solids, liquid, and gases emit, absorb, or transmit radiation to varying degrees. And by Stefan Boltzmann law, black body is the idealized surface that emits radiation at the maximum rate. And we have the formula, heat is equal to the emissivity of the substance multiplied by the Stefan Boltzmann constant multiplied by the area of the surface times the temperature of the surface raised to 4. Emissivity is a measure of how closely a surface approximates a black body, from which is emissivity is equal to 1. Then we have absorptivity, the fraction of radiation energy incident on a surface that is absorbed by the surface. By Kirchhoff's law, the emissivity and absorptivity of a surface at a given temperature and wavelength are equal. As such, a black body has a emissivity equal to 1 and absorptivity equal to 1. Incident radiation is the radiation from the source of radiation. And as it hits the surface, a portion of this radiation is absorbed and a portion is reflected by the body. Although in a black body, the radiation is absorbed 100% because the absorptivity of a black body is equal to 1.